Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, IIT-Jam, Jest, Tifr and other exams related to physical science. Okay. So today I'm going to start to solve PYQs of June-November 2020. Okay, so this is the first part of the series, and I'm going to solve all the PYQs of June-November 2022 of physical science. Okay, so also I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so I'm going to start. I'm going to start with first question. Question number first. Okay. Question number first is a point mass m. Okay, a point mass m is constrained. Very good question. Constrained to move on the inner surface of paraboloid 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 of revolution equation is given, that is x square plus surface equation, that is x square plus y square equal to az, where a is greater than 0 is a constant. Okay, is a constant when it spirals down when it spirals down the surface under the influence of under the influence of gravity along z direction the angular speed about z axis is about the z axis is proportional to option A is 1 of that is independent of z, right? Obviously Option B is, this is a constant, right? Option B is Z, and option C is Z inverse, and option D is Z to the power minus 2. Okay, so this is the question, guys. Well, so I'll solve it. Now, before solving it, let me just check whether I'm audible or not. Then I'll proceed further. The angular speed. Yes, I'm audible, so I'm going to proceed further. Okay. So question is, I'll read it for you. A point mass. So we are talking about a point mass m, whose mass is m, is constrained to move on a inner surface of paraboloid. Okay, inner surface of paraboloid of revolution. The equation is given: x square plus y square equal to az, where a is a constant which is greater than a 0. Okay, when okay, and when it spirals down the surface under the influence of gravity along minus z direction, the angular speed, okay, angular speed about z axis is proportional to, okay, so angular speed you need to find out about the z axis. Okay, so this is like paraboloid, you can say this. Okay, and okay, like this, and this this point mass is spiraling down. Okay, like this. Okay, so for solving this, first we'll get the Lagrangian for this this system. Okay, Lagrangian. So we'll get the Lagrangian in cylindrical coordinate, guys. Because if you do it in cylindrical coordinate, because this the equation of surface is in this form, right? So we'll use we'll get the Lagrangian in cylindrical coordinate system. Okay, so now Lagrangian in cylindrical coordinate system. Okay, so we find Lagrangian in cylindrical Lagrangian in cylindrical coordinate system. Okay, so that L is going to be, we know, right, what is the Lagrangian? That is half in cylindrical coordinate system, guys. Note this is Lagrangian is half m into r dot square plus r square into theta dot square plus z dot square. Okay, minus mgz. Okay, so this is the Lagrangian, guys. You need to note down because it is spiraling down, right, along minus z direction. That's why there is a minus sign. Else it would be else the equation is this one. Okay, the normal equation: half m uh, r dot square plus r square plus theta dot square plus z dot square plus mgh. Okay, and here because the point mass is spiraling down along negative z direction, so that's why we've got minus sign. Okay, very important, guys, you need to note down. So this is the Lagrangian in cylindrical coordinate. Okay, important, right? So now we have been given this constraint, right? Surface of equation, that is this one, inner surface of paraboloid, right? This is given, the equation of paraboloid inner surface is given, right? So we'll write, and given, since we have been given x square plus y square equal to az, right? And in cylindrical coordinate system, we know x equal to r cos phi and y equal to r sine phi, right? We know. So this one, and z equal to z. This is in cylindrical coordinate system. Okay. Okay. Now we'll put value here. In place of x is r square cos square phi plus r square sin square phi is going to be equal to a z. Z is z, right? This is in cylindrical coordinate, guys. Very important. I'm sure you know it, but I'm just writing it. Okay, this one. So this is going to be r square cos square theta plus sin square theta is 1, right? You know, equal to az. So from here, value of r square equal to az. Okay, or we can get also value of r square equal to az. Okay, this is the important. Or similarly, value of z also we can find out. Value of z equal to r square upon. These two results are important. Okay, well, r square by a, and this is r square equal to az. Okay, well, now what we are going to do is we'll put the value of z in equation. This is a, let's say, equation 1. Okay, in equation 1, and since we have z equal to this one, r square upon a, r square upon a, right? R square upon a. So we can differentiate it. So z dot is going to be z dot means we are differentiating with respect to t. So this is going to be 2r r dot upon a. 2r r dot upon a. Okay. Well, now we'll put this value of z and z dot in equation 1. Okay. So then Lagrange is going to be L equal to, we'll put equation here, right? So this is half m r dot square plus r square theta dot square plus z dot square, this one z dot square, right? Z dot square means this whole square. So this is going to be 2r r dot upon a whole square minus, we'll put the value of z. Z is r square upon a, so minus mgz, right? mgz. So minus mg r square upon a, mg r square upon a, right? So this is the Lagrangian, guys. Okay, this is the Lagrangian. So we have given the inner surface equation of paraboloid, right? And by that we have got value of z and z dot, and we have put that value in Lagrangian. Okay. Now, because here we can see that that particle, that point mass is moving, the spiraling down, right? So in this case, we can see that theta is cyclic coordinate. Okay, here since theta is cyclic coordinate, okay, theta is cyclic coordinate, it means del L over del theta equal to 0. That implies value of J is going to be, or that implies del L upon del theta dot, that value is going to be equal to J. J is the angular momentum, right? Okay, so this means value of J equal to this one, del L upon del theta dot. Okay, very important, del L upon del theta dot. This is very important result, guys. Okay, you need to know. Important result. Okay, this one, and this is also very important. Okay, so because it is because theta is cyclic. Okay, the particle is spiraling down, right? Now, so we'll find the value of J. So J is del L upon del theta. L value is this. will differentiate this L with respect to theta. So this is going to be with respect to theta dot. Okay. So here you can see this is going to be constant. These are constant values. Only this will be will differentiate with respect to this, right? So this is going to be this one, half m half m this is going to be r square, and the differentiation of theta dot square is going to be 2 theta dot, right? 2 will get cancelled, so value of j equal to m r square theta dot. Okay, theta dot is, that is angular velocity, right? Angular speed. Theta dot means that is angular velocity, d theta upon dt, right? Angular speed or angular velocity, right? This is theta dot. So from here we can get value of theta dot. Theta dot value is going to be j upon m r square, right? And that's what we need to find out, the angular speed, right? Angular speed. Now value of r square we know from here. So r square is az, so we'll put the value in place of r square, we'll put r az, right? So this is going to be, this implies theta dot value is going to be j upon m az since az equal to r square equal to az, right? M az. So from here, that angular speed theta dot is angular speed, right? Angular speed is, we can see that is inversely proportional to z, or theta dot is proportional to z inverse, right? That is, angular speed is proportional to z inverse. So this is the answer. Okay, so which option is matching, guys? Option C is matching, guys. Okay, so option C is the correct option. Okay, I hope you have understood it, guys. Well, so this is the question. Okay, very good, very good question, guys. So for solving this question, you should know the Lagrangian incidental coordinate system. Okay, very important, you need to note down. Okay, and then you have given the equation, the surface equation, inner surface equation of paraboloid. From there you put you got the value of z. You have put that in Lagrangian, and because theta is cyclic coordinate, so it means del L upon del theta equal to 0. That implies value of j is del L upon del theta dot. So we'll differentiate Lagrangian with respect to theta dot, and we'll calculate it, and then we'll get the value of theta dot, that is the angular speed. Okay. Well, next question, guys. Next question. Next question is, question second. Next question is, two coupled oscillators. It's a good question, guys. Two coupled oscillators two coupled two coupled oscillator two coupled oscillators in a potential two coupled oscillators in a potential V, which is function of xy, is equal to half kx square plus 2 2xy plus half ky square. Okay, so two coupled oscillator is in the potential of this form. Okay, half kx square plus 2xy plus half ky square. Okay, and where k is where k is greater than 2. K is greater than 2. K is greater than 2 can be decoupled. Okay, can be decoupled into two into two into two independent harmonic oscillators. Independent harmonic independent harmonic oscillators. Two independent harmonic oscillators. Okay, and coordinates are x dash comma y dash. Okay, respectively for these two harmonic oscillators. Okay, x dash y dash by means of by by means of by means of an appropriate an an appropriate an appro an appropriate transformation that is x dash y dash equal to s x y Okay, the transformation matrix S is the transformation matrix S is okay. Options are, option number A is 1 upon root 2 1, this is matrix. Okay, 1 minus 1 upon root 2. Okay, this is the option 1. Okay, option B is 1 by root 2 minus 1 by root 2 1 by root 2 1 by root 2. Okay, this is option B. Option C is 1 by root 2 minus 1 by root 2 minus 1 by root 2 and 1 by root 2. Okay, and option D is 0 minus 1 1 0. Okay, so this is the these are the options, guys. Okay, question is given, so understand the question. Question is two coupled harmonic oscillator. Okay, so there is a two coupled harmonic oscillators which is made of two harmonic oscillators. Two coupled harmonic oscillators in a potential, which are in potential half kx square plus 2xy plus half ky square. Okay, and can be decoupled into independent harmonic oscillators, and then their coordinates are x dash and y dash respectively. Okay, x dash and y dash respectively. Okay, by means of appropriate transformation. Okay, by appropriate transformation, which is this. Okay, x dash y dash equal to s x y. Okay, the transformation matrix as s is, so you need to find out transformation matrix s. Okay, so I'm going to solve it. So here you need to note down, guys, it's important. The normal modes of given potential is, okay, so we have been given potential is this k half kx. So you need to know this potential, guys. Okay, note down this potential. This is half kx square plus 2xy plus half ky square. Okay, this is the potential. Okay, so the normal modes of given potential is, okay, the normal modes of given potential. Normal modes of given potential are, you need to note down, okay, are 1 by root 2 and 1 by root 2. Okay, 1 by root 2 and 1 by root 2. This is 1. These are normal modes. Okay, normal modes of given potential are 1 by root 2, 1 by root 2, and minus 1 by root 2, minus 1 by root 2, and 1 by root 2. Minus 1 by root 2 and 1 by root 2. Okay, in the normal, in the basis of normal mode. Okay, in the, okay, so these are the normal modes of given potential. Okay, so these are, so 1 upon root 2, 1 upon root 2, and minus 1 upon root 2, and 1 upon 2. So in the basis, in the basis, in the in the basis of, in the basis of normal mode, basis of, in the basis of normal mode, basis of normal mode, the potential can be mode, the potential, normal mode, the potential can be diagonalized. Okay, potential can be diagonalized. Okay, so the normal modes of given potential are this, and in the basis of normal mode, the potential can be diagonalized. Okay, so it means, so these are the normal modes. Okay, so it means uh, the transformation matrix S is going to be, these are the modes. Okay, these are the modes of given potential. Okay, these are the modes of given potential. So transformation, if we know the modes, okay, and in the basis of normal mode, the potential can be diagonalized. Okay, so if we know the this, if we know the modes of given potential, then the S is going to be the transformation matrix. S is going to be, just will write this in the matrix form. So 1 upon root 2, 1 upon root 2, minus 1 upon root 2, and 1 upon root 2. Okay, so this is the transformation matrix, guys. Okay, so you need to know the normal modes of given potential. Okay, these are 1 by 2, 1 by root 2, 1 by root 2. This is minus 1 by root 2, 1 by root 2. So matrix, this transformation matrix S is going to be 1 upon root 2, 1 up, minus 1 upon root 2, 1 upon root 2, 1 upon root 2. Okay, so which option is matching, guys? Option B is matching, guys. Let me check. Option B. This one, 1 upon root 2, 1 upon root 2, minus 1 upon root 2, 1 upon root 2. Okay, so this is the answer, guys. So you need to know this. Okay, next question. Next question is, that's a good question, very good question, guys. Okay, conceptual question. I'm going to solve it for you. Question is, a heavy particle, question third, a heavy particle a heavy particle of rest mass m of rest rest mass m while moving while moving while moving along along the positive z direction along the positive z direction along the positive z direction decays into decays into two identical two identical light particles with rest mass is given, guys. Okay, with rest mass small m rest mass small m rest mass small m where capital M, which is greater than 2m. Okay, small m. Okay, the maximum value of the maximum value of the momentum maximum value of the momentum that any one of the lighter particles one of the lighter particle one of the lighter particles can have in the direction perpendicular to the z direction is okay. Options are 1 upon 2 c is that speed of light. Okay, capital M square minus 4m square. Option B is 1 upon 2 c capital M square minus 2 into small m square. Okay, and option C is c root capital M square minus 4m square 4 small m square. Okay, now on option D is 1 by 2 mc Okay, so this is the question, guys. Very good question and conceptual question, and I will explain it for you. Okay, So question is a heavy particle. So we have been given heavy particle of rest mass m. Okay, so it means the heavy particle has a relativistic velocity. Okay, so heavy particle of rest mass m while moving along z direction. So it is moving along z direction, decays into two identical light particles. Okay, it gets decayed into two identical particles. Okay, with rest mass m, with rest mass small m, where capital M is greater than twice of small m. Okay, the maximum value of momentum that any one of lighter particle have. So you need to find out the maximum value of momentum of any one of the lighter particles have. Okay, in the direction perpendicular to z direction. Okay, so momentum we need to find out. Momentum of light particle, any one of the light part, maximum momentum of any one of light particle, we have to find out whose direction is perpendicular to z direction. Okay, this is the question. So I'll solve it for you. Very good question and conceptual question, guys. So pay attention carefully. Okay, well, so now, so I'll show you by figure. So this is a particle m. Okay, heavy particle m whose momentum is p. Okay, whose momentum is p. Okay, v velocity it's going, whose momentum is p. And similarly, there are two small particles. Okay, we can calculate it side by two small particles. This has mass m. Okay, and this is its direction. This is momentum p2, in the z direction. Okay, so this is z direction, guys. Momentum p2 in z direction, and this is momentum p1 which is perpendicular to z direction. Similarly, this is a particle 2 whose mass is m. This is momentum p2 for it, right, in the x direction, and sorry, z direction, and momentum is at p1 along, this is at the perpendicular, at the direction which is perpendicular to z axis. Okay, so this is the case. This is a heavy particle moving, relativistic particle gets decayed into two particles. Okay, and this is the momentum of this particle m, whose momentum is p2 along z direction. This is also moving in z direction. Okay, right. Positive z direction, and similarly other particle, this is a other particle of same mass, identical particle, which is whose momentum is p2 along positive z direction, and these are the p1 and this is the p1 momentum p1 along the direction which is perpendicular to z. Similarly this. Okay, so this is the case, guys. Now we'll use conservation of energy and conservation of momentum to solve it. Okay, so according to conservation of momentum, okay, according to, so the momentum of heavy mass is p. Okay, and momentum of light particle is p2 along z direction, p1 along perpendicular direction to z. Okay, according to conservation of momentum, conservation of momentum, conservation of momentum we know that p, the total momentum, that is p, is going to be equal to p2 plus p2. Okay, along z direction. Okay, this is along z direction. Okay, so this is because its momentum is p2, its momentum is p2, and the momentum is conserved, right? So this p is equal to p2 plus p2, right? So from here value of p is going to be 2p2, right? And we can, this implies value of p2 is going to be p by 2. Okay, okay, so very important equation 1 you can say. Next is this is the momentum of mass m. Okay, so this is momentum of mass m, capital M we are talking about. Okay, so P equal to P2